Set types. A set object is an unordered collection of distinct hashable objects. Unlike the sequence types, no specific indexes are associated with the elements of the set. That is why they are called unordered. Only immutable type objects are hashable, and hence sets can contain only immutable types, that is, numeric types, tuples, strings, etc. Though sets can hold only immutable objects, they themselves are mutable. The mutator methods will be discussed in this video. Set objects can be created by making use of literals, that is, a pair of curly braces, or by using the class constructor set. Let's see an example to understand this. Over here, we have created a set using the literals. When we print my set, all the elements of the set are printed over here. It is to be noted that the elements are not in a particular order. The type is class set. Let us see another example where we are using the class constructor. In this example, we have a list, a tuple, and a string. On all of these, we are putting the class constructor set to convert it into set and then printing them. So when we do this, the first output is 1, 2 and the string quick fox. This is because the first set was converted using the class constructor over the list, in which the unique elements were 1, 2 and the string quick fox. Similarly, in the tuple, there were repetitions of 1, 2 and quick fox. So when we convert it into the set and try to print it, another same set is printed. That is 1, 2 and the string quick fox. When we try to convert the string quick fox into a set, all the alphabets of this string are converted into the elements of the set. Note that if there are any repeated alphabets inside this string, they will also be considered only once. Let's talk about supported operations. The first operation is membership operation. If we have a set having 3 elements, 1, 2 and a string quick fox, when we try to find whether 1 is in my set, it will give us true because 1 is in the my set. Second, we try to find out this string u in my set. Since my set is having the entire string quick fox, it is not having this particular string having only one alphabet u. So it gives us false. Then we find out k not in my set. Since this string is not there in the my set, it will give us true. Similarly, we can also find out the size of sets using the len function. If you have a set and you apply the len function over my set, it will give us the number of elements in the set. For the first set, we have 4 elements, which is 1, 2, the string quick fox and a tuple having 5, 8 and 9. In the second set, we are trying to put a list into the set. This is not allowed because list is unhashable. So it will raise a type error saying unhashable type list. The third operation is equality check. If we say we have 2 sets, my set 1 and my set 2, and try to print whether they are equal or not. Over here, in this case, it will say true because all the elements of my set 1 are also present in my set 2. No extra elements are present in any of these sets. Therefore, they are equal. Now let's talk about the class methods. We have set.addElement, set.update iterable, set.remove element, and set.discard element. Let's see an example and understand these methods more clearly. Let's say you have a set having the elements 1, 2 and quick fox. For the first time, we add 46 to the set and then we try to print the set. Let's see the output. So the first output over here is having 1, 2, 46 and quick fox. Therefore, the 46th number has been added to the set using the add function. So we can simply say that this set.addElement function simply adds the element to the set. Next, we are writing set.update 1, 3, 5. This is an iterable over here. This will add all the elements in the iterable to the set. So when we try to print my set, over here we also have 1, 3 and 5. Since 1 was already there in the set, it is not added again. 3 and 5 have been added over here. Then we write myset.update and a tuple. So all the values of the tuple, that is 11, 13 and 15, have been added to the set. Then we are writing myset.remove2. This function removes the element from the set. If the element is not found, key error will be raised. Since 2 is already there in the set, it will be removed from the set and the set will be printed without having the element 2. Next we have the function myset.discard13. This function removes the element from the set. It will not raise any error if the element is not found. So 13 has been removed from the set and the set is printed. Next we write myset.discard99. Since 99 was not there in the set but you have used discard over here, it will not raise an error and simply print the set. In the last line we are writing myset.remove99. Over here remove function will raise the error which is called the key error. This is because 99 will not be found in the set. 3 more functions are set.difference, set.intersection and set.union. Let's see an example and understand what they mean. Let's say you have two sets. They are having the given elements. First of all, we are trying to print myset1 dot union myset2. In this case, all the elements of both the sets will be printed without repetition. In the second line, we are writing myset1 dot intersection myset2. In this case, all the common elements between both the sets will be printed, which is the quick fox string, the element 9 and element 7, since they are common to both the sets. Third, we are writing myset1.difference myset2. This means you have to print all the elements of myset1 which are not inside myset2. These are 1 and 2, since they are in myset1 but they are not in myset2. This difference function can also be written by using the minus operator. So over here, both the outputs will be same. Next we have isSubset and isSuperset function. Let us also see an example to understand this. Let's say we have two sets. My set 1 is having 1, 2, a string quick fox, 7 and 9. My set 2 is having a string quick fox, 7 and 9. So over here, when we try to print whether my set 1 is a subset of my set 2, by subset we mean that all the elements of my set 1 are inside my set 2. Since this is not the case, it will print false. In the second line, we are trying to print whether my set 2 is a subset of my set 1. Since all the elements of my set 2 are there in my set 1, it will print true. Next, we are trying to print my set 1 is superset of my set 2. That means all the elements of my set 2 are inside my set 1, which is true. So it will print true. The next line is just opposite. It is trying to find whether my set 2 is a superset of my set 1. This is obviously going to be false. Another function is set.isDisjoint. This function returns true if both the sets have do not intersection between themselves. So my set 1 and my set 2 over here have no common elements. So when we print my set 1 dot isDisjoint my set 2, it will give us true.